Starting off. Good day, class, professor, and anyone else who might be watching this video. Today we're presenting a lab on limiting reagents, on determining the limiting reagents. What is a limiting reactant? A limiting reactant or limiting reagent is a reactant in a chemical reaction that determines the amount of product that is formed. So, based off the image provided, it's basically just what defines how much of something that can be produced. As seen here, we have 5 sausages and 4 buns, but to make a hot dog, we need 1 of each. So we can only make 4 hot dogs because there's only 4 buns. Next, we have a few definitions for common used terms in this type of lab. Solubility. Solubility is the ability of a substance to dissolve in another substance, the solvent. A dielectric constant is the measurement of a solvent's ability to lessen the electrostatic forces between charged particles, and it is measured by its dielectric constant. A limiting reagent is just a reactant that is consumed entirely first, reducing the amount of product made. The theoretical yield is the highest quantity of product that can be produced from the limiting reagent. And a precipitate is a solid that is formed from the reaction of 2 aqueous solutions, and it forms an insoluble product. The yield percentage is just the product after doing the formula, the actual yield over the theoretical yield times 100. What is the concept of limiting reactions? A limiting reactant is a substance that is used up completely in a reaction. When this is used up, it limits the amount of product that is produced. In this experiment, we have 2 aqueous solutions, Na2CO3 and CuCl2. This eventually forms 2 NaCl aqueous solution plus CuCl3 solid. This is a double displacement reaction that forms a precipitate because the spectator ions are removed to give a net ionic equation. An aqueous solution of copper 2 chloride was combined with an aqueous solution of sodium carbonate. In this reaction, when the 2 solutions were mixed, they reacted chemically to make a blue solid called copper 2 carbonate and a clear solution of sodium chloride. The net ionic equation becomes Cu2 plus CO3 2 minus to form CuCO3 after the spectator ions NaCl are removed. The blue precipitate showed that a reaction happened by looking at how much of the reactant was used. It was possible to find the limiting reactant, which was the one that used up completely in the reaction.
Okay, so breakdown of the procedure. 1 ml of sodium carbonate solution was mixed with 1 ml of copper 2 chloride solution in a test tube, and it was stirred, and the observations was recorded as seen in the images. 0.4 gram of each power sodium carbonate and copper 2 chloride was weighed for trial 1 and trial 2 in separate figures. Each solid was dissolved in 10 ml of distilled water and stirred for a minute. The observations were recorded and compared with test tube mixture. A Buchner filtration apparatus was set up, and the filter paper was labeled and weighed. The mixture was poured into the filter paper and then watched. for trial 1 was repeated for trial 2. These solids were then dried in an open plate, and the filter paper plus dry precipitate were weighed for both trials after one night. For trial 1, it was weighed to be 0.69 gram, and for trial 2, 0.63 grams. After the dry precipitate were collected in a whisk.
Okay, for the tables, for our data tables, we see that this copper chloride solution was a sky blue color and it was a liquid solution. And for sodium carbonate, we had a clear, colorless liquid solution. When mixing these two, the solution became cloudy and a precipitate started to form. After stirring it, even more precipitate started to form. For our measurements in trial 1, the mass of copper carbonate was 0.399 grams, and for trial 2 was 0.4. The mass of the salt was 0.51 grams for both trials. The mass of the salt and the precipitate for trial 1 was 0.69 grams, and for trial 2 it was 0.63 grams. And for the mass of the copper carbonate precipitate for trial B it was 0.18 grams, and for trial 2 it was 4.12 grams. What we can see here, our reactant when testing with sodium carbonate, our limiting reactant for trial 2 turned out to be copper chloride, and excess was also copper 2 chloride in our trial 1. The filtrate for this was a slight blue solution in trial 1 along with a colorless solution for trial 2. For trial 1, this filtrate of copper chloride was colorless solution, as well as the trial 2 filter appearance. The limiting reactant was sodium carbonate for both trials. In our last table, we can see the calculations using our molar mass and mass of our precipitates. We can then see that it was found that there was 1.456 moles times 10 to the negative third for copper 2 chloride and sodium carbonate. Using the molar mass ratio to find the amount of grams that was for the mass of copper 2 chloride, it turned out to be 0.196 grams, and for sodium carbonate, that was 0.154 grams. From our previous table, we remember that our mass of our salt mixture was 0.51 grams, and we can see our limiting excess reactant there as well. The mass of our excess reactant from having the initial minus reactant gives us 0.203 grams, and to find the percentage yield of the copper chloride mixture, that gives us 61.4%, and for sodium carbonate that is 38.6%. In trial 2, the calculations are about the same, just that our percent yield for copper 2 chloride instead is 25.7%, and in sodium carbonate it is 78.4%. Now we move on to the analysis / discussion questions. As previously stated on previous slides, questions 1 and 2 were already answered, so we are moving on to discussion question 3. The answer for discussion question 3 is that trial 1 turned out to be a slight blue color as seen from our table, and the limiting reagent was sodium carbonate, with trial 2 being also with trial 2's limiting reagent being copper chloride, and it was a colorless solution. For the fourth question, we can see that the actual product yield is often lower than our theoretical maximum because of some limiting factors like an incomplete reaction, product loss due to dissolubility, and physical losses. As for example, in the video seen before, some of it could not have been filtered properly, along with when it's being scraped to weighing the mass would not have been properly scaled, or it could have fallen off.
Okay, so for question 5, what was the percentage yield for this reaction? So for try 1, the percentage yield for copper 2 chloride was 61.4%. Percentage yield for sodium carbonate was 38.6%. And in trial 2, the percentage yield for copper 2 chloride was 74.25%. And percentage yield for sodium carbonate was 25.75%. So, so, so based on the result, it was successful but not fully, perfectly done, and ways to improve this would be that ways to improve what is to make sure that it fully reacts by stirring the solution longer and more evenly. The results for question 6, the results of one student's experimental results for this exercise showed a percentage yield of 115%. Provide a plausible explanation other than gross errors in weighing for how this might occur. Okay, so to explain this, it could be due to impurities such as sodium carbonate or copper 2 chloride. Any one of these may have been trapped in the solid, and so therefore the filter paper may have absorbed or retained some of the solution, therefore adding some extra mass and affecting the student's result. For question 7, a student in a hurry poured the reaction mixture from the beaker very rapidly into the Buchner funnel such that some of the mixture ran around the edge of the filter paper. What effect is this expected to have on the student's determination of percentage yield? So to explain that is, if the mixture runs around the edge of the filter paper, some of the precipitate will escape filtration and it won't be able to be filtered. And this will cause it to lose some of the product, and it can lead to a lower actual yield, and with a lower actual yield, it will affect the percentage yield. So to explain this is that not all copper carbonate will be collected and weighed, so the students would definitely underestimate how much of the product was actually produced.
In conclusion, reaction between copper chloride and sodium carbonate successfully produced a copper carbonate precipitate, which was the original goal of this lab, showing that the limiting reactant cannot cause the entire thing to dissolve, but only shows that we need a specific amount to react in a chemical reaction, which limits our end goal. And thank you for listening.